Welcome to Reflections Labs, Results and Explanations. Today we are going to go over the results of our Reflections Labs and explain why we got those results. So please make sure that you've completed your labs before viewing this video. First up, we're going to discuss our Reflection Labs results. Let's go with lab number 1, mirror, mirror. So the first thing we were supposed to do was write our name and look at it in the mirror. What do you notice? You should have noticed that when you wrote your name and looked at it in the mirror, it appeared backwards in the mirror. For the second part of the lab, we had to write our name as it appeared in the mirror. What did you see? When I wrote my name backwards and looked at the reflection of it in the mirror, it actually appeared correct. Here's what I wrote and looked at in the mirror. The one that's written backwards looks correct in the mirror, and the one that's written correct looks backwards in the mirror. Finally, you were supposed to write the alphabet and figure out which capital letters look correct in a mirror as they do when you look at them on your paper. So which capital letters in the alphabet look the same in the mirror as they do on paper? Well, you should have gotten A, H, I, M, O, T, U, V, W, X, Y. What do those letters all have in common? So what do they all have in common? Well, those letters are all symmetrical. So they are the same on one side as the other. So if we were to fold each one of those in half, they would look exactly the same on either side. So in the mirror, they appear correct. But why? It's all because light travels in straight lines. So when light is hitting a reflective surface like a mirror, it's reflecting in those straight lines too. So the mirror image that you see is actually reversed. Think about it, when you look in the mirror, your face is reversed from what people actually see. Next up, we're going to talk about our second lab, foiled again, and our results. First, you were supposed to look at your reflection on a smooth piece of foil. What did you see? You should have been able to see your reflection in that foil when it was smooth. Next, you had to crinkle the foil and then look at your reflection in the wrinkly foil and see, how did your reflection change? So when I looked at my reflection in the crinkly foil, I actually couldn't see a thing. It was very different than the smooth foil. There was nothing there. So why did we get those results? Well, remember, light rays are reflected from a surface in straight lines. The once smooth surface is now all bumpy. Because of the reflected rays going off on all different directions, your image does not form the way it did when a surface was smooth. Your reflection has vanished. Next up, let's discuss A Spoonful of Reflections. What you were supposed to do first was get a large metal serving spoon and then look at your reflection in the spoon. What do you see? When you looked at the inside of your spoon, you should have seen your image upside down. Then you were supposed to look at your reflection on the back of the spoon. When I did that, I could see my reflection the correct way. So why the different results for both sides of the spoon? It's all about how light travels. Light travels in straight lines, and it gets reflected in straight lines too. When light is reflected from a curved surface, the rays bounce off at different angles. The reflected image appears upside down because of the angle of the reflected rays of light. That's also the reason your reflection looks so silly when you look in a funhouse mirror. Aren't those fun? All right, let's go ahead and look at lab number 4, the magical cylinder. We know it's not really magic, it's science. For this lab, you are supposed to explore and show how different lines, drawings, words, or objects look in the magical cylinder, and how do they look different. One thing I noticed in this lab is that the images that we started with were very stretched out and also curved, just like the surface of the magical cylinder. So once again, light's traveling in straight lines and it's getting reflected in straight lines too. When we look at a curved surface like the magical cylinder or the back of the spoon, when we looked at different kinds of lines in the magical cylinder, I could see that anything that was straight appeared curved in the magical cylinder, and anything that was curved appeared straight. It's all because light is reflecting from that curved surface and it's bouncing off in a straight line. Writing words also helped me see how the image was reflected upside down. All right, it's time to talk about lab number 5, the Scientific Paperclip. In this lab, you were to fill a glass half full with water, drop a paperclip or other small object in the water, and look at it from a higher level so you can see 2 paperclips. Why do we see 2 paperclips? Well, it's because of reflection. The water reflects the light from the paperclip, so you can see 2 paperclips. Finally, lab 6 was your reflective choices. You got to locate and share at least 2 reflective surfaces. And what about them reflects light? Since I can't share your reflective choices lab's results, let's go ahead and talk about our reflections lab's explanations. We learned that light waves travel in straight lines, and we also learned that they bounce off an object they strike. When light waves strike an object with a smooth and shiny surface, the light waves bounce directly back to your eyes at an equal angle, causing you to see your reflection. This can also happen on a smooth and shiny surface, like on a lake or a pond. To reflect means to bounce off a surface. But what if the surface is not smooth and shiny? When light waves hit an object with a bumpy surface, they bounce back in many directions. The light waves bounce back at various angles. This causes you to see that object rather than your reflection. What kinds of surfaces reflect light well? Smooth and shiny surfaces reflect light well. What are some examples of good reflectors? Some good reflector examples are water, glass, mirrors, shiny plastics, and metals. We also learned that bumpy surfaces do not reflect light well. They actually bounce the light back in many directions. Be on the lookout for other examples of reflections. You never know where you're going to find some connections to our science concepts. All right, that's it for me. Take care.
Peace.